JEE Advanced 2025, Paper 2, Physics, Question 3. This is a single correct answer question worth plus 3 marks, with -1 for wrong answer. Let us look at the setup. A uniform rod O' of length L is hinged at point O at the bottom and held vertically between two walls using two massless springs of the same spring constant K. In Figure 1, one spring is at the midpoint and another at the top end O'. In Figure 2, both springs are connected at the midpoint of the rod. The rod oscillates with small angular displacement. We need to find the ratio of frequencies, F1 by F2. Here is the question. A uniform rod O' of length L, hinged at O, held vertically between two walls by two identical springs. In Configuration 1, springs are at the midpoint and at O'. In Configuration 2, both springs at the midpoint. We need the ratio F1 by F2. The options are A, 2B, root 2. C, root of 5 by 2. D, root of 2 by 5. Let us solve this step by step using the torque method for small oscillations. The key concept here is simple harmonic motion of a rigid body hinged at one end. When displaced by a small angle theta, the restoring torque is tau equals minus I alpha, where I is the moment of inertia. The frequency of oscillation is F equals 1 over 2 pi times root of K effective over I. The springs provide restoring torque. When the rod rotates by angle theta, a spring at distance d from the hinge exerts a torque of K times d squared times theta. Now let us compute for each configuration. Step 1. The moment of inertia of a uniform rod of mass m and length L about one end is I equals ml squared by 3. Step 2. In Configuration 1, the spring at distance L by 2 from the hinge contributes a restoring torque of K times L squared by 4 times theta. The spring at distance L from the hinge gives KL squared theta. The total restoring torque in Configuration 1 is KL squared theta over 4 plus KL squared theta, which equals 5 KL squared theta over 4. So omega 1 squared equals 5 KL squared over 4, divided by ML squared over 3. Solving this gives us 15 K over 4M. Now let us analyze Configuration 2. In Configuration 2, both springs are at the midpoint, distance L by 2 from the hinge. Total restoring torque is 2 times K times L by 2 squared times theta, which equals KL squared theta by 2. So omega 2 squared equals KL squared over 2 divided by ML squared over 3, giving us 3K over 2M. Step 4. The frequency ratio F1 by F2 equals omega 1 by omega 2, which is the square root of omega 1 squared over omega 2 squared. Substituting, we get root of 15K over 4M times 2M over 3K. The K and M cancel out, giving us root of 15 over 6, which simplifies to root of 5 over 2. Therefore, F1 by F2 equals root of 5 by 2. The correct answer is option C, root of 5 by 2. Let us verify the other options are incorrect. Option A says 2, which would mean omega 1 squared is 4 times omega 2 squared, that does not match. Option B, root 2, would require a ratio of 2, also incorrect. Option D is the inverse. Only option C, root 5 by 2, matches our calculation. Excellent. Let us now look at some important exam tips. Tip 1, for simple harmonic motion of rigid bodies, always use the torque method. Write tau equals minus I alpha and identify the restoring torque. Tip 2, when a spring is at distance d from the hinge, its torque contribution is K times d squared times theta. The d squared factor is crucial. Tip 3, when finding frequency ratios, first compute omega squared for each case, then take the ratio and simplify. This avoids errors with square roots. Tip 4, remember key moment of inertia formulas. For a uniform rod about one end, it is ml squared by 3. About the center, ml squared by 12. Tip 5, when the problem says ignore gravity, the equilibrium position is simply the vertical configuration and you only need to consider spring torques. Keep these tips in mind for JEE Advanced physics problems on rotational dynamics and oscillations. If you found this solution helpful, please like and subscribe to MAGPIEHUB for more JEE Advanced solutions. See you in the next one.